Welcome everyone. I'm Justin Vaughan-Brown in Product Marketing with AppDynamics. I'm very pleased to see you all here today. This presentation, I think, is a really, really relevant one. If you'd seen the keynote earlier today when you heard everyone talking about velocity, and this is really focusing on the twin pressures of delivering high-quality applications at very high velocity, yet maintaining that extremely high customer quality to ensure customer retention, customer acquisition, and so forth. So I'm really, really pleased today. We've got a tag team here. We've got Mike Bonamassa and Mark from CapitalOne, and Mark Lambert from Parasoft, a leading testing and integration vendor, who will take us through their story. Just to kick us off is actually Mark, a fellow Brit. You'll notice by his accent, so we're here in force today. And over to you, Mark. Thanks very much.
Thanks, Justin. So yeah, my accent's a little bit more Americanized in places, but not very much. So my name is Mark Lambert. I'm the Vice President of Products at Parasoft, and we've been working with CapitalOne for a number of years now, helping collaboratively build out that acceleration of DevOps and continuous delivery. So before we kind of jump into it, we really want to talk about, obviously everybody in this room has heard DevOps, they've heard about acceleration, and you've probably also all experienced the risks and the challenges associated with that. There's typical challenges that most organizations face, which is around brand quality and equity within your brand. That's obviously one of the key things associated for CapitalOne, but also within industries such as safety critical, we at Parasoft work with those customers as well, helping them integrate DevOps and the continuous testing practices so that they can accelerate continuous delivery while mitigating the business risk associated. Now, the challenge that most people face is everybody should be familiar somewhat with this sprint diagram. The challenge is that while I've got a product backlog and I'm rapidly building through my features and I'm implementing my functionality, I'm making a lot of change into my code base. And what I have to do is I have to somehow figure out how to test not only the new functionality, but also existing functionality. Now, the trouble is, I don't have enough time in that 2 to 3 week time window. I somehow have to be able to take what would be an automated test that might require a lot of systems and infrastructure to be stood up, and somehow figure out how I can turn it from an automated test into a continuous test. If I can't do that, then really this acceleration and this push from the business, this acceleration to deliver new functionality into the product set is going to lead into a lot of testing in production, which, while it sounds great to say, hey, let me just push something out to see if it works and then I'll roll it back, that often isn't a real world scenario for many organizations. The business risk associated with that is just frankly too damn high. Now, the problem is, we no longer own one application. Our application is built up of many, many subsystems. Those systems might be owned by my company, but a different business unit, or they might be a completely different third party. How do I know if it's going to all work when I put the pieces together? Well, each of these pieces is typically connected together through some level of API. Traditional technologies like MQ, for example, but more commonly these days, RESTful services or SOAP-based transactions within some enterprise-level deployments. So I know I can actually test my individual piece, the piece that I'm responsible for, but the problem is that guy doesn't live in isolation. He's connected to other pieces of my infrastructure. So while I might have tests which I know I can run at any time that I want against my infrastructure, I still need access to those other back-end dependencies so I can test my functionality out. The way that we solve this is by using a technique called service virtualization. With service virtualization, what we can do is we can emulate the dependencies of those downstream components so I can start assembling my jigsaw puzzle together with a variety of different jigsaw pieces in different states. Basically, I'm simulating the dependencies. This frees me up and gives me a lot of flexibility into how I can deploy and how I can test my infrastructure. So I can go from a test, for example, that is running as part of an automated QA cycle, a test that takes me 24 hours to set up the infrastructure and then only 2 hours to run it. I can take that test and start to run it earlier in the development cycle. I can shift left that testing process. So what types of things can we emulate with service virtualization? And there really is a very broad range of different types of jigsaw puzzle that I can emulate or simulate. Often organizations do focus on RESTful services, focus on web services because they're well understood, they're easy to manipulate. But the other types of technologies, many organizations still have legacy systems, leveraging proprietary mainframe protocols, for example, leveraging MQ, which requires a broader test infrastructure. I might also have direct calls to my database over JDBC, and I might want to be able to emulate that. That's what we can do with service virtualization, in that we can emulate these different types of communication, be them a message layer communication over something like HTTP, JMS, MQ, or be it a database call over something like JDBC, or even mainframe transactions as well. Typically, what you're focused on is you're focused on two things. You're focused on the transport, how the message or how the two pieces are communicating over the wire. And then you're also focused on the format or the actual transport. You're focused on the protocol or the actual message that's communicated over the wire. Typically XML or JSON, but also could be things like EDI, fixed length messaging, copybook format data. The goal here is to be able to assemble a test infrastructure that's highly flexible and highly reconfigurable so I can test at any time and any place. Dynamically, basically standing up my infrastructure and then destroying the functionality that's been stood up. Now, we're going to talk about specifically how CapitalOne have been leveraging both service virtualization, but also how they've been changing their organization so that it really is made up of a fungible development organization that allows you flexibility within the team itself. But the core technology that can help you with that enables flexibility in the team, but also removes a number of constraints. The typical applications that I see for service virtualization fall into really three buckets. The first is automated to continuous. And again, I talked about this a moment ago. So being able to say, okay, I've got an automated QA test that has dependencies on some infrastructure, and I want to be able to run it at my CI time immediately when I do check-in. I don't want to have to wait until I'm at the end of the sprint or getting close to the end of the sprint, because typically if you're finding your problems at the end of your sprint, you're going to have a lot of things to do at the beginning of your next sprint. So you want to be able to run these tests somehow in a fully automated manner. Now, service virtualization allows me to simulate my dependencies so I can focus on just testing my underlying code. It doesn't eliminate the need for integration testing with those system dependencies. But what it does is it does free you up. So I'll use an analogy. One of our clients in the stock industry, so what they do is they actually have a number of development streams that are building their trading platform. Okay, as they go to do test, those development teams need to line up in a queue and say, okay, every 4-hour time window, a new development team is allowed to go into their integration system and run their tests. So they have a scheduled time and a scheduled access to test infrastructure. The problem here is if you're not ready when your 4-hour window comes along, you don't get your 4-hour window back. If you find a problem in the first 10 minutes, you don't get your 4-hour window back. So what they're able to do is by using service virtualization, able to make sure that they're prepared going into that time window so they can maximize the time that they have available. So that's really what turning automated into continuous is all about. It's how can I make my automated tests more valuable to me earlier in the development process. The second example is what we see typically within Agile development organizations. Here, what you have is a highly collaborative ecosystem where development teams are working on different services that come together to provide some overall piece of functionality. often deployed through web services or microservices as well. So this is really, the concept of microservices has exacerbated this problem in that now I've got a much tighter coupling between all my different teams so that you can end up with dependencies in your development, in your sprint dependencies. What happens here is Team A is waiting for Team B to finish doing their work before Team A can move forward. I can see a couple of smirks, so I can see that that has happened more than once. What service virtualization can help you do is Team A, they're waiting for functionality from TB. Team B can develop a prototype which is going to document what their implementation will do. It doesn't have to be fully functional, but it gives Team A something to work against and start doing their integration. Furthermore, it has a secondary benefit, and that secondary benefit is it now gives Team B something to develop against. This is where you can start to unlock the potential of test-driven development. And then the last one is where we can shift left performance testing. And this is really where we see integration with AppDynamics as being critical. So here, in fact, I'll use a specific case study as an example. So here, what we're doing is we're actually looking at how we can facilitate shift left or early stage performance testing. Now, I'm going to use a banking example. It's not a CapitalOne one, which Mike will probably thank me for that. But in this particular case, we had a client, and they were trying to performance test the code that they were getting ready to deploy into production. But the problem that they had is even though they wanted to push some very big number through their middle layer, the problem was the back-end systems that they had available to them in test were only able to perform a certain amount of threshold. So basically, they weren't able to test to 11 because their back-end systems would only support 2 or 3. Furthermore, their back-end systems were giving them all of the same response times because they're test systems, so they're not really representing real-world scenarios. What they did with service virtualization was they monitored the behavior of the current systems and built out virtual assets to emulate the current behavior of the application. So again, this isn't really an agile one. This is more of a, okay, how am I going to help you shift left your testing process? Then, by talking into AppDynamics, they were able to understand what the current performance characteristics are of that deployed system and use those performance characteristics to control the behavior of the service virtualization and therefore control the behavior of the dependent systems. This meant that they were able to go ahead and do their full stress testing, able to test that their application under test was able to handle the load that we knew that system could handle. Now, they went the next step though. And the next step was to say, okay, let's go ahead and run a number of different virtual assets with different performance characteristics. And this is where the interesting thing came. They had an external dependency, an external partner that was providing them a service. This service had a service level agreement, let's just say between 5 seconds and 1 second response time. And they were like, okay, we want to crank our system as fast as possible and see what happens, stress test everything. You know what, we want to ignore this third party. And we're going to go ahead and make that SLA for the third party 1 second. We're going to say, you know what, it's going to meet the maximum performance characteristics. And all of a sudden their application starts falling over. And they're like, oh, we've introduced some bad code, we've broken something. So they rolled back one version, they rolled back another version. They rolled all the way back to what was in production, and the system was still failing. I'm like, what is going on? So they get on the phone to us, and they're like, Parasoft, there's something wrong with your product, which, as a vendor, that's pretty usual. But we spent some time digging down with them, and we found out it wasn't a problem with our product. It was actually a hidden race condition within their live web application that all they needed to experience, for their customers to experience this production outage, that they wouldn't know why it happened. All that they needed to have was for their third party to turn around and go, great news, guys. I know we normally average about 4 seconds, but we've just put some great performance improvements in place. We're now down to 1 second. And all of a sudden, everything's crashing. So this is where service virtualization can help you remove those dependencies, but also run a whole bunch of different what-if scenarios. This is a production performance one, but different types of data. What happens if I get half a payload? What happens if my payload has funky numbers in it? Because everybody knows that the database integrity is always perfect, right? You never get some funky number or character in your database. So this is what service virtualization can do to help. But service virtualization is just a technology. Without having the organization behind that technology and using it in conjunction with together, it really isn't going to work. And this is where I'm going to hand over to Mike.
CapitalOne, and we've been on a journey for a while. We've been doing Agile techniques for a number of years. Really, it's phenomenal. We're changing the company from a typical financial institution into a technology company, and it's really inspirational to hear some of the leaders talk about it, because it's not that we can't do what the other banks do today in the same way, with the same quality. We can do all that. It's that we don't want to become the banking utility of the future when Apple or Google or someone takes over the relationship with the customer. So we've got to build these muscles. And so one of the things we're doing is we're making sure that the way that our teams work together is in such a way that everything we do is engineered to perform. And that's what I'm going to talk about today. So this is a familiar diagram, right? This is the way intent flows in, from the business. It comes in, we do design, build, test, we integrate it, and we put it out into the various environments. Now, what we don't show on here is something new that we've started to see as we're maturing. And that's that this idea over here that the business comes up with, a lot of times is really informed by stuff that happens back here. And I'll give you an example, and I'll use this example throughout the thing. One of the challenges that one of our business partners came up with was in the rewards area. So venture card, lots of rewards, really cool. They were analyzing some of their data, and they were saying that, hey, we've noticed a significant drop-off on people that execute, doing travel, because it goes to a third-party vendor. There's a lot of delay in there, and anytime it's over 6 seconds, the drop-off is dramatic. You see a lot of duplicate requests and stuff like that. And so the business said, hey, we want to fix that. And we're also rethinking the vendor relationship, so stuff like that. So they didn't know what they needed here. They knew what they saw back there, but they didn't know what they needed here. So what they needed to do was find a way to experiment. So how do we simulate what it would be like if we made the vendor sign up to a 2-second SLA on response time, that allowed us to get in? Now, how does our code have to perform in order to make that 2 seconds all fit within the window that the business wanted to do? So that's what we're talking when we're talking engineered performance. It's bringing some of that experimentation back to the forward discovery process that the product managers are using actually in the business area. So I'm going to talk a little bit about how we do that. So the first thing we do is it all starts with production. Production is this wealth of information. It was amazing today when I heard about the billions of, was it 100 billion transactions or measurements that are being taken in the SaaS product. It's amazing. So there's this wealth of information that's out there. So the first thing we have to do is we have to instrument our production system so that we can start to collect this information. We also have the ability to put Parasoft out there and actually start collecting some of the data associated with that. Now, Parasoft has provided us with a really rich environment to be able to collect actual data, but also do some simulation of data and stuff like that. So with this, we're able to understand the way our systems work, whether they're on-prem, cloud, or hybrid. By the way, this whole technique that we're talking about, a lot of this stuff has been done in the experimentation. There's some person-in-the-loop stuff that we're moving away from. But it's really only enabled with a cloud-based approach. With a regular, traditional on-prem, it's really difficult to do. But we can get all the information from any of those. Now, once we have that information, the goal for us is based on the context of the task we need to do. So in this case, it was very early, the business saying, we need to know how our part of the system performs. We need to know what the SLA needs to be for the partner that we're going to select in this, and how that needs to perform. And then we want to see what that would do by basically running through a simulation and then saying, what would our system look like if we looked at real transactional data that had these performance characteristics? How many more transactions could we process? Because obviously getting those tickets out to people is a huge customer benefit. So in order to do that, we had to figure out how do we create a minimum realistic environment for the particular perspective that the developer wanted to test in the particular context that the business felt was important. Because we had all of the information from AppDynamics and the ability to virtualize it, we were able to look at that. And this is where some of the performance engineers had to be, people in the loop from the initial experiments we did. They were able to look at it and they were able to say, okay, here's some interfaces that are involved, in this particular context that we're talking about. And when we look at the performance characteristics of those interfaces, some of them were highly deterministic, responded in 1 or 2 milliseconds or something like that. Very, very good. Some of them were highly variable. 5 milliseconds, 30 milliseconds, 100 milliseconds. It's kind of all over the place. And it didn't necessarily correspond to load. So one of the things we needed to do is we needed to be able to say, for those deterministic interfaces, because we knew it from the APM data, we can actually just simulate that at the initial call. For the more variable ones, we needed to look through those interfaces and figure out what portions of that call stack could we actually simulate and what portions of those had to flow through. And potentially even flow through. We've used this where we've actually had to flow it through to APIs that are working in production in some cases to actually get the real data when we didn't have a sophisticated enough approach. So in order to do that, we built out a tool internally called Hercules. And Hercules is a tool that not only allows us to bring our performance tests in, it allows us to define the characteristics of the environment that we want to see. And based on the characteristics of the environment, it can look through all the data that was collected in production and help us build out that particular environment. So the developer, to be able to do the task they need to do, simply has to describe what it is they want to do to Hercules. Hercules will load the proper tests in, build out the proper environment scripts, go and build out the environment, run the tests, pull all the data back into the dashboard, and destroy the environment. That was the only way we were able to get the engineers to be able to shift left the things that they were doing. In a traditional world, and we still have this in a lot of our areas, we have performance testing environments. And those performance testing environments are great simulations of what occurs in production, but they're also cherished environments. I mean, they're constantly being run. We have a lot of teams that every time they deploy, they run their code through this performance testing environment, and the performance engineers don't want anything else running in that. They don't want a developer running an experiment in the performance testing environment because it pollutes it, right? So we had to figure out how to solve it, and that's what we did. By using the combination of these two technologies to give us the data we needed, and then starting to use the technologies to simulate using the virtualized stuff, and then validate it. That was equally important. So once we had simulated the environment, we built it out and we ran the test, we had to actually have that minimum realistic environment instrumented as well so that we could verify that that environment was performing the way we expected in production. So we were using AppDynamics again, the non-prod environment, to do that. And it was really interesting when we went through and did this stuff. We found a lot of things that we didn't expect. I mean, there were times where it's like we did everything the right way, but the non-prod environment is not responding the way that the production environment responds. Why is that? And so I was just in another session a couple minutes ago, and he was talking about how getting engineers involved in the ops side of things or seeing the way things really work stimulates curiosity, and that's exactly what it does. Is you start to see variances in there, and the developers, engineers start to understand those variances, and they start to try to figure out and dig through and find out what it is that's causing that. Again, that's only possible by us being able to create these realistic environments early on in the life cycle. So some of the things we had to do in order to do this is we had to take some of these different specialized skills and capabilities, and we had to use the fungible word again. We had to try to create full stack software engineers that were able to do all of these specialist things without having specialists available to them. So there's a great Harvard Business Review article out there about the different stages of automation. And kind of the first stage of automation is robotic process automation, okay? And that's what you get with Jenkins and stuff, where you're taking, what a person does and you're having a machine do it instead. That's robotic process automation. The more challenging one, and where we're working right now, is in the cognitive automation. How do we take the knowledge that a DevOps engineer or an ops engineer or a performance engineer would have, and codify that in software so that it becomes usable by a full stack software engineer. Because when we talk full stack software engineers, we're not taking engineers that now are performance engineering specialists, are system engineers, you know, and all this stuff. They're full stack software engineers that have some understanding of that, but the software's got to handle that complexity. We've got to embed that, and that's what cognitive automation is. So we're building in the ability for the engineers to be able to specify, again, this is what I want the environment to look like. Here's the perspective that I'm testing from. Here's the context that I'm looking. And the system has to be smart enough by looking through the data to figure out what it needs to do to reflect that for the engineer. If we required the engineer to do that, they wouldn't be able to do it without a lot more training or without relying on a bunch of specialists, which doesn't scale. So we started building in the cognitive automation. The next step for us, and we're still early days in this, we're going to be doing this for a long time, but the next step is the robotic social automation, which is where now if we're doing this and we start to have these validation environments in place that are validating the tests that we're doing, we can also start to say, based on that data, what could we possibly suggest changes in production environments based on data we're seeing that are in the non-prod environments that are instrumented as well. So let's say we run a test, a simulation, and we're able to reduce the time in a particular interface down to 1 second from 5 seconds or something like that. What does that do to the actual system? Well, now if we then go and we build this capability into the software, we're able to use that to start to push out to the ops folks and say, here's how you would make different settings on your load balancer or something like that. Because now with this performance, you're going to be able to spin up instances quicker and stuff like that. And so you won't have to have quite as low a threshold. So we might be able to have a deeper saturation in the servers and the instances that we're doing. So we can start to use some of the information that we're getting out of that instrumented non-prod environment that's simulating where we're going with it and start to push that out into the production environment to give us advanced understanding in that so that we can tune those environments before we actually go live into production with it. So this is a journey that we're on, and it's incredibly fun to do it. It's really cool to work for a company that allows you to do this kind of experimentation and stuff like that, and isn't really just focused on the bottom line in every aspect. So it's been real fun to do that. But it hasn't been super fun for the developers and the performance engineers in all cases, because they've had to change. So our performance engineers, our testers, have had to become much better at engineering. So they really need to understand the technologies, the languages. We've also had to take some of our performance testers and really turn them into performance engineers. They really need to be system engineers. They need to be able to look at the comprehensive system and understand why things are performing that way. Because regardless of how good we become at creating these tests and automating it for the engineer, when weird stuff happens, a lot of times the engineer really just can't figure it out. They need a performance engineer to come in and help them understand the characteristics of the environment that they're running in so they can help them troubleshoot some of those things. So we've had to make changes to the role of the performance testers. We've also had to make changes to the role of the developer, or the engineer. They've had to become more and more responsible for the code that they're developing, for how that code performs, considering performance early on in the life cycle, being open to, and this was a really strange one for us, because we were doing Agile for a long time. But as soon as the business started to finally get the power that they have in the product manager and product owner roles, and come in and start talking about experimentation and discovery, the developers were very much like, no, just tell us the requirements. Tell us what you need. Give us the stories, and we'll get it done. They're like, well, I don't know what we need. We just want to try this. So it really required the developers become much more open, much more out-of-the-box thinkers in terms of how they can particularly solve problems that are unconstrained or novel or unknown problems that they had before with the business. So it had them thinking about ways of working together differently. We also started using a lot more pairing in there, and this was particularly true when it came to some of the testers working in tandem with the engineers. So the engineers, even when we had automated some of this stuff, still some of the engineers weren't comfortable with running the performance tests and looking at the analysis that came out from it. And so the pairing allowed us to get over some of those challenges there, so that there was able to be more comfort in them working together. I think that is all I had on this, I don't know where this came from. Is this?
That's the feedback slide, yeah.
This is a feedback slide.
Yeah.
Okay, cool.
So I think we both probably went a little faster than we did in our practice.
Yeah, we did. We thought it was going to be 15 minutes each. So
yeah. So
I can try my British accent.
Probably not a good idea. So really, at this time, any questions that you guys have for myself or for Mike?
Yeah.
Please.
First of all, do you have a CapitalOne card in your wallet? Next question. No, just kidding. Just kidding. Go ahead.
When it came to configuring virtualization to simply services, et cetera, from a perspective, because I'm actually a company, how did you account for that virtualized service to be able to calculate the expected load in real world?
For response time goals and data related? Yeah.
Yeah. So
we should probably repeat the question. So
Yeah,
the question
yeah.
is, how are we able to use the virtualization to actually create a faithful simulation in terms of response time and actual data responses?
So there's a couple of different ways that we can do that. So first of all, you can do the obvious thing. Hey, this is going to respond at 4 seconds. This is going to be 40 milliseconds, whatever. But that's just a static number. What you need to do is you really need to have an asset that responds that, hey, when I'm being hit really heavy, I want you to reduce my my performance. And so what we can do within Parasoft Virtualize is we can actually model exactly that behavior. So you can map out and say, okay, when you've got a low amount of traffic coming through to the asset, make it very highly responsive. When you've got you can draw a bell curve, you can do whatever you want to be able to do within that environment. And then we can use the data from AppDynamics to seed that to give you an initial starting point, and then you can go ahead and start modeling and then kind of do additional polls from AppDynamics as needed.
So you can account for transaction rates.
Transaction rates, yeah.
That's exactly it. We use the data that comes from AppDynamics to give us our response curves, and then we basically just model in Parasoft exactly how we want it to respond, and it responds the same way. So, and that's where I was talking about where sometimes if it doesn't, we didn't call Parasoft and say there's a problem with their software. It's more like what is wrong with our environment that it's not responding the way we would expect it, because it does respond the way we tell it.
You had a question?
Yeah, I was wondering, as you got going from the pump, got it started, how much work was that to get it set up and going, or you could automate a lot of this stuff?
So I'll let you take that one first.
Yeah. So the question is, to prime the pump to get it going, how much work was that? It's a lot of work, but it wasn't. I'd be lying if I said we were big brains and we thought of all this stuff up ahead of time. It was really a lot of experimentation and putting different pieces together. And this also isn't like ubiquitous across all development teams in CapitalOne. There's still some teams that are, in on-prem environments doing, waterfall development, and there's other teams that are, highly agile. But it really took us, I would say, from the time we got Parasoft in here, I'd say it was probably about a year when we started to recognize the benefits of being able to virtualize and use actual production data to drive that simulation, and then use that production data to find out what aspects we would want to virtualize and what aspects we'd want to call through. It took us probably about a year to do that. And it started in our organization called CODE, which is CapitalOne Digital Engineering. So it was in the digital mobile space that saw that benefit first.
And really the key there is to take it incrementally as well. So, what with working at CapitalOne, the thing that we didn't do is to say, okay, we've got to build the whole thing day one, right? What you do is you build incremental successes, and then they chain together. So there's often when I'm talking about how much time to invest in a service virtualization asset, there's a trade-off as to how much functionality am I going to put into an individual asset versus, how much functionality is actually going to be used. So using the 80-20 rule of life, you just build a whole bunch of small, simple assets you can switch in and out for different use cases, and then reconfigure your test environment. But the key is, as Mike was saying, was kind of building towards that and identifying where the return on investment is going to be for the organization and getting there incrementally, I would add.
That asset, you think 80% of the use cases that were used the most and built?
Yeah, I mean, I would say it's not always 80% the ones that use the most, because sometimes, yeah, so sometimes they actually, the ones that use the most represent the use cases which are really hard to do. So what you're trying to do though is you're trying to shift left as much testing as possible to say, okay, if I've got this small number of very valuable test cases, but I can't put automation around it, let me focus on doing those and have everything else done on the left-hand side. So it's definitely, you take an assessment of how complex is the interaction, how complex is the asset, and you start to prioritize things. But the key is to get some return on investment quickly.
Yeah, another part of that too is that, and this is something we do at CapitalOne all the time. When we want to do something, it's go big or go home. It's like, let's solve this problem for everyone. And we've really had to work hard to get away from that. Let the discovery of the knowledge that you need drive the focus. So again, when we're looking at a production data and we know the context and the perspective that we want to use, we can start to see what transactions are important in there. And in the past, we would have said, well, until we have everything virtualized, we create 100% faithful simulated environment, we can't do anything. Now we say it's really these 5 API calls that are the ones that we really have to focus on and do some engineering around how to virtualize those intelligently. So it really reduces the amount of work by focusing it. Yeah?
You're simulating those components, and you're looking for specific response times that you're trying to plug in, right? I'm curious about the data that you're plugging in there, because a lot of times, it's a lot more than just the response time. A lot of, it's dependent upon
Sure.
the data and the response. So how do you deal with that?
You want to talk about that?
Yeah, so typically there's typically 2 workflows for building out a virtual asset. The first workflow is possibly the simplest one, the one that most people jump on first, and that's monitoring the current behavior. So as we're monitoring the current behavior between the application and test and the dependent system, we're in essence generating traffic. And we take that, parse it, process it, and then we have a pretty sophisticated modeling process that we go through where you can extract out the data elements and encapsulate that functionality into a reusable blob, basically, where I can then start to expand the data and change the performance characteristics. The converse around that is really the kind of what I refer to as the Agile workflows, where you don't have anything to test against. There, typically what you're doing is you're using something to describe what the API is going to look like. That's either a description document like a Swagger, RAML, or a WSDL if you're talking about a web service, or it could be something as simple as an example payload. Often we find as organizations leverage REST, they might not even have a document describing it. They might just have like here's what the payload's supposed to look like. Well, we can take that, throw that into the product, emulate it, and then start building out additional data and parameterizing the responses. So when you've got something coming in, you're requesting the price of an apple, it'll give you 25 cents. When you're requesting the banana, it'll give you 50 cents, whatever. And parameterizing that through the use of data.
Yeah, we've also, go ahead.
CapitalOne, and you monitored production level data. Do you have some kind of like a de-identified?
Yeah, I was just going to say we built a tool internally in our test data management group called OneSource. And what OneSource does is it takes out NPI type data, PCI type data, scrubs it, but we can generate any kind of data we want now with OneSource. Now, when it's a new API or something, that's typically where the dev team that wants to have their API be able to be registered in OneSource has to provide us with sample data and sample rules associated with it so that we can start to emulate some of that data early on. But yeah, we definitely take production data and scrub it.
But that's your tool that you built?
That's our own internal tool we built, yeah.
Yeah. And within the virtualized product, there's some capabilities around data masking when you're actually wanting to obfuscate that data. But typically what we find is that organizations have a very mixed environment. So somebody like CapitalOne might have their own proprietary stack. Other customers that we work with have other technologies that they've already embedded into their infrastructure as well.
Any more questions?
Thank you very much for the mic, Mark.
Great. Thanks very much,
Thanks,
guys.
appreciate it. Good evening, yeah.